Hi, this is Bill Miller, and I'd like to talk briefly about the use of simulation in OpenStat. I have OpenStat on the screen, and I'm going to click on the simulation menu and demonstrate two or three of the simulation uh, options. The first one is the theoretical distributions option, and with that one you can select one of many different theoretical distributions. I'm going to click on the binomial for demonstration of both the cumulative distribution frequency and the probability distribution frequency. You'll notice that there are some parameters already given for both of these. If I click on the cumulative distribution function, you get a graph of the CDF. If you click on the PDF, you get the probability distribution function. Again, we can change these parameters. For example, the number of successes could be changed to, for example, 15. If I then press the Enter key and compute the PDF, you'll see that the shape of it has changed based upon the number of successes. The same thing could be done with the other cumulative distribution function. We'll exit this one and look at another simulation, and that is the simulation for a multivariate distribution. The multivariate distribution allows you to create data for two or more variables. I'm going to press 3 variables, and when I do that, a grid shows up for me to enter data. I'm going to enter a data value for the matrix, and that will be a 1 for each of the 3 values. And I'll put in some data for the correlations between the values. I'll put in like a 0.8 or 0.6, I should say. I put in a 0.2, and I'll put in a value of minus 0.3. For means, I'm going to enter values similar to test scores. I'll give each of them a value of 100, and I'll give standard deviations of similar to those of a intelligence test, for example 30, and I'll do the same for each of the 3 variables so we can compare those sample data that are actually generated. So we now have our data defined, and I'll click on the Continue button, and it's now asking for the number of cases. I'll generate, say 500 cases, and press the Enter key. Now we have the parameters shown on the output, and we'll see if the data that are generated actually are somewhat close to those. I'll click the Return button, and I'm done with my data generation, and I'm going to analyze it with the correlation, product correlations with all the values, and get means and standard deviations also. When I do that, I can compare the sample data with that which I generated from population parameters. You'll notice the means are fairly close to 100, and the standard deviations are fairly close to 30. So that demonstrates the generation of data that are very helpful in terms of testing various programs. I'll do one more simulation. I'm going to go to the very bottom one, that's Generate Probabilities, and click on a subheading called Normal Functions. For this one, I'm going to look at the probability between two z values under the normal distribution. The first one I'm going to put in is a minus 1.96, and for the positive value, the same value, plus 1.96. When I calculate I compute the results, I should get the proportion of the normal curve between these two values. And you see that the result is close to 95%, 0.949999. Again, this simply is an option under the simulation. You should explore many of these other ones to see what value they might be for you. For example, plotting a z-distribution. If the alpha level is the default 0.05, you'll get a plot of the z-distribution with the area 0.05 shown on the picture. So that's all I'll demonstrate on the simulation, and I encourage you to explore other simulations. Thanks for watching. If you have questions, feel free to write to me, or also check your reference manual.